All right. Hey guys. So I'm gonna cover the rest of the algorithm design questions that Chris did not cover, and yeah, this video might come later in this playlist because I made the other tutorial videos, and those probably came first. But either way, this is for CS170 review session for midterm 1. My name is Raymond, and let's get started. Let's see. Where's my? Oh, it's kind of annoying. Okay. Oh, okay. Here. So don't look at the question title, but I'm given 3 subsets of a set of integers that are contained, like we know the integers has to be between 1 and n, and I want to know whether which of the elements from C can be written as a sum of a pair of elements from A and B, right? And I can only take one element from A and one element from B, add them together, check if this element is in C. So in this case, I would have 1, 3, 4 as A, B as 3 and 6, and I have 2, 4, 5, 6. And I know that I can get 4 from I get 4 from 1 and 3, right? And I get 6 from 3 and 3. So let's get started. We don't want an n-squared solution. We want a faster one. So let's move on to my other page. Okay, so same questions here, but now I have more space to work with. All right. Okay, so the thing that we see here is that we need to do some a of I plus a b of j and basically check is in C, right? I need to make this check. And I don't want to make every crosswise pair, right? Because of n elements here, n elements here, crosswise check, combination check is going to give me an n-squared solution. So what we're going to make use of is we're going to make use of the fact that if I take a of I to a power, and I multiply this power by x of b of j, what I'm going to get is the exponents are going to add each other, right? The exponents of a multiplication is going to add, I'm going to add the ai plus bj together. So what we're going to do is we're going to somehow set x, right? So what we're going to do is we're going to make polynomial multiplication. If I form a of x as this a of 0 plus x to the power of a1, nah, it doesn't matter, x of a1 plus x of a2 plus all the way to x of an. So same thing for this. I have x of b1 plus x of b2 plus x of bn. Now, if I do a multiplication between ax, let's call this a of x times b of x. Sorry, not very creative, but it's fine. What I'm going to get is I'm going to get so here, this is going to be a summation over x ai's for ai in a. This is going to give me a summation of b of j and b over x of bj. Now, this is going to give me a summation of ai in a, b, j in b of x of ai plus bj. Okay, now that I have this, I can take all the non-zero coefficient terms of the power and check whether this power term is in my is in C or not, right? Because every one of these terms contain all the possible combinations of adding them together due to polynomial multiplication. So I can just take this non-zero coefficient term and check whether it's in C. If it is, I keep it as my set, otherwise I won't. And if we use polynomial multiplication via FFT multiplication with fast Fourier transform, we're going to end up getting as a n log n solution. because making this polynomial takes n time, right? Multiplication takes n log n. Checking everything takes n time. And checking whether this is in a set of integers takes amortized constant time. So together it's linear time. So this is just going to equal n log n, right? So let's do this example. I have a of x as a x1 plus x3 plus x4. I have b of x as x3 plus x to the 6. I'm supposed to make use of this page, but that's fine. So if I do cross multiplication, polynomial multiplication, I'm going to get x to the 4 plus x to the 6 plus x to the 7 plus x to the, oh, that's weird. Yeah, 7 plus x to the 9 and plus x to the 10. I check at every one of these and see whether it's in C or not, right? Is 4 in C? Yes. Is 6 in C? Yes. 7, 9, 10? No, none of them are in C. That's fine. I'm going to return the set, and there we go, right? And the proof is basically, you should do inductive. No, the proof is just very simple, right? It's just saying that I need to make these combination pairs, and I can do this with a polynomial multiplication due to how exponents, the way if I multiply exponents together, they become, if I multiply powers together, the result is an addition in the power term, right? And that's how we obtain our sum. And using that, we can find whether it's in MSSC. And we use non-zero coefficients because multiplication can give me like 0 times x to the 8, and it's not in here, right? Only the values that's in here do we check against C.